An endpoint is a device that connects to an organization's environment. Laptops, desktops, servers, and virtual machines are all examples of endpoints. These systems matter because they are where people work, files are opened, credentials are used, and business applications run. Attackers often target endpoints because a compromised endpoint can become a foothold. From there, an attacker may steal data, install malware, capture credentials, move laterally, or reach other systems. Even when strong network and identity controls exist, endpoint activity can reveal what is actually happening on the device. Endpoint detection and response, or EDR, exists because organizations need visibility into these systems and a way to respond when suspicious activity appears. EDR is not a magic shield. It is a visibility and response layer that helps defenders understand endpoint behavior and act when something looks wrong. Endpoint detection and response is a security capability that monitors endpoint activity, detects suspicious behavior, supports investigation, and helps responders contain or remediate threats. The detection part helps teams notice unusual or risky activity. The response part helps teams act before an incident spreads further. EDR tools typically collect telemetry from endpoints, such as process execution, file activity, network connections, registry changes, login activity, script execution, and suspicious command line behavior. This telemetry gives analysts a more detailed view than a simple allowed or blocked message. The goal is not only to block known malware, the goal is to help security teams understand what happened, how far it spread, and what action should be taken next. EDR is especially useful when an event is not obviously good or bad, and the analyst needs context. Traditional antivirus focused heavily on identifying known malicious files, often using signatures. That is still useful. Known malware should be blocked when possible, and prevention remains an important security layer. Attackers do not always rely on obvious malware files. They may use legitimate tools, scripts, stolen credentials, or built-in operating system features. EDR looks more broadly at behavior. A strange PowerShell command, a process dumping credentials, an unusual parent-child process relationship, or a suspicious outbound connection may all matter. EDR does not replace prevention. It complements prevention by helping defenders detect and investigate activity that gets past earlier controls. The practical difference is that older antivirus often asks whether a file is known to be bad, while EDR also asks what the endpoint is doing and whether that behavior makes sense. EDR telemetry is the activity data collected from endpoints. Common examples include process starts, command line arguments, file writes, network connections, user logins, privilege changes, script activity, service creation, scheduled tasks, and registry modifications. A single event may not mean much by itself. The value comes from context. A command line tool might be normal for an administrator, but suspicious on a receptionist's laptop. A network connection may be normal for one application, but strange for another. EDR helps analysts connect events into a timeline so they can understand whether activity is benign, suspicious, or malicious. That timeline can show what started first, what process launched another process, which user was involved, what network destination was contacted, and what files changed. EDR is not only about detection, it also supports response. Depending on the tool and permissions, responders may isolate a host from the network, kill a process, quarantine a file, collect forensic data, search for related indicators, or trigger remediation actions. These capabilities can reduce the time between detection and containment. If a laptop appears to be spreading malware or connecting to a known command and control server, isolation can help prevent additional damage while analysts investigate. If a suspicious file is found, quarantine can reduce exposure while preserving information for review. Response actions require judgment. Isolating a critical server may disrupt business operations. Killing a process may destroy useful evidence. A good EDR workflow balances speed, evidence preservation, business impact, and risk reduction. EDR is powerful, but it is not magic. It can be misconfigured, ignored, bypassed, overwhelmed by alerts, or limited by poor coverage. If endpoints are unmanaged, offline, excluded, or not sending telemetry, defenders may have blind spots. EDR works best when it is deployed broadly, tuned carefully, monitored consistently, and connected to incident response processes. Good practices include maintaining endpoint coverage, reviewing high-value alerts, tuning noisy detections, documenting response procedures, integrating with SIEM or SOAR where appropriate, and training analysts to investigate endpoint behavior. EDR is one layer in a defense-in-depth strategy. It does not replace patching, identity security, network monitoring, backups, user awareness, secure configuration, or incident response planning. Its value comes from reliable visibility, useful detections, practiced response, and human judgment. Endpoint detection and response helps organizations monitor endpoints, detect suspicious behavior, investigate activity, and respond to threats. EDR goes beyond traditional antivirus by focusing on behavior, telemetry, investigation, and response. It can show process activity, command lines, file changes, network connections, logins, scripts, and other endpoint events. EDR supports containment and remediation, but it still requires good deployment, tuning, monitoring, and human judgment. EDR is not a magic shield. It is a visibility and response layer within a broader security program.